We discussed at the beginning of topic 5 that work leads to a change in energy. We're now going to go from our original definition of work, where work equals the force net times displacement, remembering that the force and the displacement have to be parallel to each other. So I've written our original equation here just generically, because it could apply in the x or could apply in the y, but we have to remember that the force and displacement still have to be parallel to each other. We are going to use this relationship to get to a point where we can discuss work in terms of a change in energy. So the first substitution I've done here is for force net, I put in mass times acceleration. So this is simply Newton's second law. Over on the side here, I've written one of our kinematic equations, the fact that the velocity squared equals velocity initial squared plus 2 times acceleration times the displacement. And I've rearranged this equation. I first subtracted the v initial squared to the other side, and then I divided by the 2. So that velocity final squared minus velocity initial squared divided by 2 is equal to acceleration times displacement. And you'll notice that we have acceleration times displacement here, and we have acceleration times displacement up here. So what I have done is replace this acceleration times displacement with the relationship that equals this acceleration times displacement, because they're the same thing. So you'll notice here we have velocity final squared minus velocity initial squared divided by 2, and I subbed in up here velocity final squared minus velocity initial squared divided by 2. And in the next line, I've simply distributed the mass and the 2 to both the velocity final squared minus the velocity initial squared. And this is what we call the work energy theorem. So this relates work to energy. And specifically in this case, it is being related to the kinetic energy, where the kinetic energy is equal to 1/2 mass times velocity squared. And we're going to say kinetic energy, so let me write out kinetic energy, is the energy due to an object's motion. And we know this because it has velocity in the relationship. So we can say work equals kinetic energy final minus kinetic energy initial, or work equals the change in kinetic energy. So this allows us to see that if we do work on an object, it has a change in velocity or a change in kinetic energy. And well, I want you guys to remember the origin of this formula, because it helps you remember when work is done or when work is not being done, because we made it a little bit more complicated, because before we were just worried about whether or not the force and the displacement were parallel to each other, but we have to remember that for force, it's mass times acceleration, and acceleration means that there is a change in velocity, a change in motion. So in order for work to be done, there actually has to be a change in velocity of the object. And we're going to keep expanding on the other side this idea to get other types of energy, and we'll talk about that in future lecture videos. However, keep in mind that I'm expecting you to be able to apply the work energy theorem and the idea of what kinetic energy is. I'm not asking you to replicate these steps up here to get to this formula. I expect you to be able to apply this formula.